that is transducer. So we use the transducer in all the fields of mechanical engineering. So we study this in the mechanical measurement for transducing the input signal into the analogous form. The input signal, which is maybe deflection or any changes in physical quantity that can be transduced from, for example, the input signal is transduced into analogous signal. Analogous signal is converted into voltage signal. Then the voltage signal is transduced into digital signal. From the digital signal, that is converted into the digital output. So all of you see in the weighing machine. Then next come to the point, the transfer efficiency. Say, this is very, very important for all the mechanical engineers. That is for any system. For any system, you don't have 100% efficiency. Can you get the 100% efficiency in any machine tool or in any engine or any component or any measuring instrument? The transfer efficiency is always less than 1. That is less than unity. Less than unity. That is nothing but you have always the transfer efficiency which is less than 1. Say first consider what is transfer efficiency. The transfer efficiency can be defined as, that is the input I in to the transduced form I out. The I out can be related as I out equal to, that is the output from the transduced form, that is the function of I in, and the transfer efficiency is defined as ratio of I out to the I in. See, all of you remember the transfer efficiency of any measuring instrument or any machine tool or any motor or any pump, that is always less than unity. That is always less than unity. That is nothing but you have the efficiency 60% or 80% or 90%. So this is very, very important for calculation of performance characteristics of the engine. Say you have engine slab in 5th semester, there you have to calculate performance characteristics of 4-stroke diesel engine, 4-stroke petrol engine, and a 2-stroke petrol engine. So transfer efficiency is very much essential for calculation of performance characteristics of any system. Next come to the point, say any measurement, you have 2 types of transducers. One is primary transducer, other one is secondary transducer. The primary transducer receives the input, that is the measuring method or the input to the primary transducer. For example, measurement of taper on the component, that is the dial indicator move on the taper component. For that reason, the plunger moves upward direction, that is the input to the primary transducer. The primary transducer in case of dial indicator is rack and pinion arrangement. Rack and pinion arrangement. In between that, the plunger movement, that is the instrument analogous form. The dial indicator, you can call it as instrument that is in the analogous form. The primary transducer is the rack and pinion arrangement in the dial indicator. Next come to the point, the secondary transducer, the measurement of taper. The secondary transducer is rotation of the dial. Rotation of the dial. The pinion and the rack which turns in the clockwise direction, so that the dial rotates more than 1,000 times, more than 1,000 times. So depending upon the type of measurement, the dial rotates in the clockwise direction more than 1,000 times. That is the secondary transducer, which gives the output, that is the movement of the plunger from one point to the other point. So that is in any measurement, the input and output, that is nothing but the transduced form. The output always that is in the transduced form. The input to the system that is transduced in the primary stage. Again, the instrument is between. Again, you have the instruments in between primary and secondary transducer. Again, here one more transducer which is transduce the signal into the required form where you have the output. That output is coming from the secondary transducer, which converts the output coming from the primary transducer, which is converted into the form, and again it is transduced and it gives the output. That is in any measurement, the primary transducer and the secondary transducers are very, very important. Next, come to the point. The transducers are classified into electrical transducer, electronic transducer, mechanical transducer, like that. So, for example, good example is electrical transducer is LVDT, linear voltage differential transform. Remember, the electrical transducer is the linear LVDT, linear variable differential transformer. LVDT, linear variable differential transformer, is considered as electrical transducer. Next, come to the point, very, very important. All of you say the electronic transducer. Say the electronic transducer. Say this is the plunger. This is the plunger. Here you have the deflection of the plunger because of movement of the plunger in the upward and downward direction. That is the displacement of the plunger. Next, come to the point. Here you have the flexible diaphragm. Flexible diaphragm. So almost all of you seen the diaphragm in the speaker. So all of you seen the diaphragm, that is the black color flexible diaphragm present in the speaker. The same type of diaphragm made of PUC material or some other material is placed between the plunger and the movable plates. Plunger and the movable plates. Whichever the deflection coming from the displacement of the plunger, which is transferred to the flexible diaphragm, that is transferred to the plates, which is fixed on the tungsten filament, which is fixed to the tungsten filament. You have a rod which is connected to the terminals. So these terminals are connected to the millivoltmeter or milliammeter. Milliammeter. Once again, the electrons transducer consists of first the plunger, next flexible diaphragm, the spring, that is the spring-like filament. It is made of tungsten, and this filament is connected to the plates, and the plates, between the two plates you have a rod, one end is sharpened, and this rod is connected to the terminal, So this terminal is connected to the millivoltmeter or milliammeter. Millivoltmeter or milliammeter. First, if you want to check the surface roughness of the component, so usually the surface roughness of the granite block which we have in the metrology lab. All of you seen the granite block on which you are performing experiments. So that is the surface of the granite is finished up to mirror level. If you see your face in the granite block, that is, if you observe your face on the surface of the granite block, it is called finishing of up to mirror like finish on the granite. That is called mirror finish. Say the surface is polished and produced mirror finish by using lapping and other grinding operations. Say in this context, now you just go through the electronic transducer. What is the function of electronic transducer and what is the output? Say here, the electronic transducer is used for measurement of surface roughness of the surface plate or granite block or any component. You have mirror finish. First, what are the components present in electronic transducer? This is the plunger. And the plunger is fixed to the flexible diaphragm. The other end of the plunger, see the other end of the plunger, just like a X joint, that is connected to the tungsten filament. All of you observe here, the spring-like tungsten filament is fixed to the one end of the plunger. The same plunger end is placed on the diaphragm by using any flexible cement, or you can say the PVC gum or any adhesive. From that, they fix the one end of the plunger. The same plunger, that is the other end of the plunger, which is placed outside the diaphragm. It looks like a T joint. So that is one end of the displacement is placed and fixed on the diaphragm. The other portion is fixed on the other part of the diaphragm. It is fixed to the tungsten filament. The tungsten filament has two plates which moves up and down. Due to that, there will be change in the electric current. Remember, due to the movement of the plates on the tungsten filament, there will be change in the electric current due to the movement of the plunger up and down. That plunger movement is passed to the tungsten filament through the flexible diaphragm. Say that flexible diaphragm is nothing but a transducer that transforms and transduces the deflection of the plunger in the more deflection, that is the amplification, that is transferred to the tungsten filament. The tungsten filament has two plates, one above and below the tungsten filament at the center. Due to the movement of the plunger, this plates moves up and down. Due to the movement of the plates, there will be change in the electric current. And the rod which is placed in between the two plates, which receives the electric current from the movement of the plate, and which is measured by using the terminal. All of you observe here, using the terminals. Once again, the principle of operation. First, before starting the measurement of surface roughness of the surface plate, See that the milliammeter showing 0 reading. Bring the milliammeter to read 0. That is called null balance. Then see that all the switches are on. Switch on all the contacts. Connect all the 4 terminals to the milliammeter and then move the plunger on the surface plate. Move the plunger on the surface plate. This plunger is connected to the diaphragm. This plunger is connected to the diaphragm. The other side of the diaphragm, you have one more plunger which is connected to the tungsten filament. Tungsten filament, which looks like a spring. On the tungsten filament, you have a movable plate. Movable plate. And after that, there will be a rod which is placed in between the movable plate. So this rod receives the electrical energy due to the movement of this plate. Movement of this plate. So the entire electronic transducer is covered in a shell. Covered in a stainless steel shell. Then this is the stainless steel shell and this rod is connected to the terminals. These 4 terminals connect these 4 terminals to the milliammeter. Then start moving the plunger on the surface of the surface plate or granite block. Due to waviness on the surface plate, there will be a deflection in the plunger that is transduced by the flexible diaphragm. The small movement of plunger movement which is amplified into the million times or 1,000 times by the flexible diaphragm. The other end of the flexible diaphragm, there will be one more plunger which changes the electrical characteristics of the tungsten filament. Electrical characteristics of the tungsten filament. In turn, the tungsten filament has two plates on the movable support. In between the 2 plates, there will be a rod which receives the electrical current. Say, before starting the experiment, you have 0 reading. After starting the experiment, the plunger moves up and down so that there will be a deflection. There is a change in the electrical characteristics. That change in the electrical characteristics changes the milliamp. That changes the milliamp. That the changes in the current that can be measured by using the terminals provided in the backside of the electronic transducer. Always the output is in milliamps that is converted into the surface roughness units. That may be surface roughness may be in microns. In microns, the milliamps is directly converted into surface roughness units that is in microns. This is the principal operation of the electronic transducer. Once again, what all the components present in electronic transducer. First come to the point. This is there will be 2 plungers. One is projecting outwards. Another one is which connects the flexible diaphragm to the tungsten filament. Then the end of the plunger is connected to the tungsten filament. The tungsten filament at the center, you have 2 plates which deflects, or due to the movement of this plunger, there will be a deflection. That deflection may be the displacement coming from this plunger is very, very minute. But this deflection, which is amplified million times or 1,000 times, then that deflection is directly transferred to the tungsten filament. Due to that deflection of this plunger, there will be change in the electrical characteristics of the electrical characteristics of the circuit. Electrical characteristics of the circuit that can be measured by using milliammeter. Milliammeter that is connected to the terminal. The terminal receives the electrical output, that's the current, change in the electrical current that is coming from the moving of the plates which is present on the tungsten filament. All of you mark it, very, very important. You may have this question in the examination. Mark it very, very important. Write down the question. Write down the question like this. Explain briefly. Explain briefly. Explain briefly. Explain briefly with neat sketch. With the neat sketch. Electronic transducer. Electronic transducer. Put a question mark. Put a question mark. List the advantages and list the advantages and limitations. List the advantages and limitations. List the advantages and limitations. Say, this is a very, very important. Almost all the question paper, you have a question on electronic transducer, and this time also you can expect this question in the examination. Mark it, very, very important. Next, come to the point. The next topic of this module, the mechanical transducer. All of you studied, all of you performed the experiment by using dial indicator. That is measurement of paper. You have already performed the experiment. Next step. Next, after starting of the class, after starting of classes, you have an experiment in the metrology lab. The study the performance characteristics of the linear variable differential transformer. This is the electrical transducer. Say you have three. One is mechanical transducer. Other one is electrical transducer. Mechanical transducer means the dial indicator. Electrical transducer means linear variable differential transformer, that is LVDT. And the electronic transducer means that we discussed today. So all of you go through this, and I will give the notes and write the diagram neatly and explain with your own words. So that is the deflection of the plunger is measured in terms of milliamps. Milliamps. And so this much is enough for this class. And listen here. Listen here. The important announcement from the college, that is, you have a online test. You have a online test maybe on 27th of this month or 4th of next month. 4th of next month. And remember, this test for 50 marks. This test for 50 marks. This is the online test. Online test. We give you the question paper. We give you the question paper. For that, you write the question, you write the answers in any sheet which you have in your house. And this is the open book test. Remember, all of you, this is open book test. You can refer, you can see any book or any media, or anything. You can write the test within 1 hour for 50 minutes, or sorry, 50 marks. Say you have a test on 27th of this month or 4th of next month. The test for 1 hour, test for 1 hour. This is the open book test. You can write the questions for 50 marks. After writing the answer, after 1 hour, we give you the 10 minutes time for scanning of your answer sheet. That is the test sheets. You can scan or you can take the photograph. You can scan the answer sheet or you can take the photograph, upload into the Google Classroom or to my email ID. Send it immediately after the test. Say, after the test, we give you 10 minutes time for taking the photograph and uploading the same thing to my email ID. Remember, email ID. The very important thing is in the first page, in the front page, in the top position, write your name and USN and class. Write your name, USN and class. From that, after completion of the test, this is open book test. You can refer the textbook or you can refer my notes. You can refer my notes and write the test for 50 marks. After 1 hour, we give you the 10 minutes time for taking the photograph of the answer sheet, then upload the same to my email ID or Google Classroom or Google Classroom. So this is a very important announcement from our college and department. From our college and our department. The test may be 27th of this month or 4th of next month. We will announce the schedule of the test. Remember, the test for 50 marks, we reduce the 50 marks into 10 marks after starting of the classes. After lifting the lockdown, you have one more test. That test is be conducted for 20 marks. So by adding both, you have 30 marks. One test for 10 marks, that is online portions covered till today. Remember, the online classes portion, the portions covered till today, you have that portion in the open book test. Say, this much is enough for you, today's class. Now I make the unmute. You have any questions, you can ask me. Anand, can you listen? You have any question regarding electronic transducer? Mehul, can you listen? Hello, Ganesh, can you listen?
Yes, sir.
Test in the gotaita. Ganesh, can you understand the test?
Yes, sir.
Guidelines of the test. That is test for 10 marks. That is, we conduct the test for 50 marks. We reduce it to the 10 marks. Okay. At this point, I stop this stage and I will continue in the next class.
Sir.
Ganesh, ಹೇಳಿ. Hello, Ganesh,
Sir,
ಹೇಳಿ.
ನಂಬರ್ ಬೇಕಿತ್ತು. ಗಿರೀಶ್ ಸರ್ ಇಂದ ನಂಬರ್ ಬೇಕಿತ್ತು ಸರ್.
ಹೌದಾ? ಕಳಿಸ್ಕೊಡ್ತೀನಿ. ಕ್ಲಾಸ್ ಆದ್ಮೇಲೆ ಕಳಿಸ್ಕೊಡ್ತೀನಿ. ಗಣೇಶ್, ನಿನಗೆ ಅಲ್ವಾ ಬೇಕಿರೋದ?